Good day. My name is Dr. Petros Kolovopoulos. I represent Hydrocom Enterprises, and I'm happy this afternoon to participate in the session for digital technologies and advanced asset management solution. The topic of my presentation is information systems for asset management, and all that within the new ISO 55001 framework. Before I start, I would like to say a few things about my company, Hydrocom Enterprises. We are an international information technology and consulting company specializing in management information systems called IDAMS, systems appropriate for utilities, municipalities, government departments. We have a long list of customers from asset management with more than 100,000 kilometers of networks, more than 40 million connections using our billing systems for solar parks, and many solutions for government departments, particularly in the environmental sector. A very good example of one of our programs is the Southeastern Europe Asset Management Program, SIAM. A lot of the other speakers already probably spoke about it. This is a stage asset management program, including a silver stage, addressing GIS and network management, gold stage, and platinum stage addressing advanced asset management issues. I'll start by saying a few things about ISO 55000. This is the newest ISO. It reflects the latest thinking and the best practices in asset management. Implementation of the framework results in improved performance, improved value of assets, effectively managing the risk, enhancing the growth of the business, reliable decision-making, and confidence for all stakeholders. All the framework for asset management is included in the standards, the international standards. It's called Asset Management System, and it includes all the requirements for the establishment, implementation, maintenance, and improvement of asset management. The framework, the heart of the framework is the SAM, the Strategic Asset Management Plan. Strategic Asset Management Plan is formulated from the organizational objectives and results in a set of detailed asset management plans. Now, the problem is, how do you get there? How a utility implements the Strategic Asset Management Plan and how the utility implements the asset management best practices. It needs a lot of components. First of it is the project management, institutional strengthening program, asset management information systems, a lot of data studies and data improvement studies, and all that to formulate your infrastructure planning. All these components are based in the two pillars, the SAM, the Strategic Asset Management Plan, and the Evaluation and Improvement System, which is a continuous mechanism, a mechanism that continuously feeds back the progress of the system implementation and improvement for the Strategic Asset Management Plan. In terms of asset management systems, the IDAM systems cover the whole spectrum of life cycle of assets, including monitoring, operating, maintaining, and upgrading, and rehabilitating and disposing the assets. But in terms of systems, they cover all the aspects of asset management, from asset registry to maintenance management, to asset management planning, to network analysis. So as I'm going to present today, the asset management systems within the ISO framework, first of all, have to include data management and maintenance management. These are the two basic systems. Then you have to address operations, that being the actual operations of the department, including quality control, including water auditing, balancing, and leak detection. And with this foundation, we can address more advanced asset management issues like asset management planning and network modeling, and all that within the framework of dashboard and management reporting. I'll start by the asset registry. This is the heart of asset management, is to capture and populate our asset registry. We need a system that understands the typical asset elements in a utility, for the different services, others for water, for sewer, for drainage or electricity. It needs to inherently understand the different type of elements that a utility maintains, so to be able to populate and guide the utility for all the attributes required. Together with building the registry, we need to formulate the quality standards and procedures. Quality standards refer to the asset registry information to be kept in terms of elements and their attributes, and also regarding the asset management information system to be operated. An example, this is a typical data quality standard describing the procedure for capturing new works by a contractor, how the information flow must be from the contractor to the asset management department, to the GIS department, and then back to the asset management department. The main issue, of course, is always how do you populate the asset registry? How do you acquire and you convert the data? You need very good conversion and structuring facilities. You need element libraries. You need to be able to take GIS data or different platforms or different software and consolidate them to one homogeneous asset registry. Or even if you do all these activities, there are major issues of how do you interrogate and how you communicate this information to the other department. The most important reconciliation is with the financial department, because now you have two registries. You have the technical registry that is the primary registry for the infrastructure, and you have the financial registry which keeps information on the assets mainly for the purposes of depreciation and balancing. These two must be reconciliated, and they must be working together, and the system must be able to export information to the financial registry and also to handle WIP, work in progress. Moving away from the basic asset registry, we have to address also operation. The heart of operation is the logs. The system must be able to handle different types of logs and communication with different basic systems like telemetry and SCADA. So a logs operation system must be able to link to control systems like telemetry and SCADA, must be able to manage the logs to do corrections and then the changes in the actual and missing values in the different log records, to calculate production and do performance analysis on bulk meters, pump stations, boreholes, and treatment plants. Such a system is used by the maintenance department, by the water quality department, and for distribution management. Once the information in the system, we can do a lot of processing, including supply flow analysis. This is very important to analyze the operation, the function of your bulk meters, to understand better what is the inflow into your different zones, and to evaluate and verify your bulk meter readings. Another aspect of operation is the quality, water quality records management. Many people confuse that with the traditional LIM system. LIM system is the information you get from the laboratories. You need a more universal system, a system that be able to take all the information from the different LIM systems, consolidate them, publish them in the data model in the GIS, and integrate with your asset management infrastructure. Another operation system is the distribution and non-revenue management. The main output of distribution and revenue management is a water audit and leakage reduction program with the purpose of reducing leakage in network, resulting in saving in production costs. To be able to enable distribution and revenue management, an important aspect is the zoning. The heart of it is the zoning. So your asset management system must inherently have tools to assist the utilities in validating, in managing, monitoring, and controlling the zones. Zone managers should be able to perform dynamic zoning by recording changes in the network with time. If we're able to do that, if we're able to record from the bulk meters all the records, if we're able to understand our zones, and if we know the consumption within our zones, we're in a position to perform water auditing for each of our zones. This is made possible by comparing the supply and demand for each discrete zone, and the results are displayed all the IWA performance indicators, which automatically are calculated for each zone. So this is the top-down approach, but at the same time, if we have the link to our SCADA system, we can implement active leakage as recommended by IWA. Active leakage is vital for cost-effective and efficient leakage management. So for each zone, we compose a graph that addresses and monitors the minimum night flows and the trend of the minimum night flows to see when we have to have an immediate intervention within each one of these zones. Leaving the operations, we come into maintenance. Maintenance and the maintenance records are very important for asset management. And to keep them properly and keep all the required information is required a customer-focused solution that is optimized for remote maintenance and field service operations. So the objective here is to computerize the maintenance function, the call center, to address incidents, and to computerize all the work order cycle. The outputs of a maintenance management system and the other components are also very important. So a lot of management reporting comes out of maintenance management, job costing information, proper budgeting, performance indicators, reliability analysis, all these aspects which they require a separate presentation, a separate day just to discuss some of them, but all important ingredients of proper maintenance management. Having maintenance in place and having condition assessment in place, we are in a position to do valuation of our different assets. An objective of asset valuation is to provide input for rehabilitation planning, for replacement cost and remaining useful life. And asset valuation is an important component of asset management planning, being its purpose to minimize cost of ownership, risk of failure, and improve level of service. The output of the planning is a rehabilitation plan and a preventive maintenance plan. So, as you know, out of the ISO standards and all the practices, best practices, maintenance and rehabilitation planning is risk-based. You require a risk assessment before finalizing the rehabilitation plan, and based on the risk assessment, you formulate the prioritization lists. The rehabilitation plan, end of the day, is a list of activities with different timeframes for asset replacement or repair within your budgets. An aspect of infrastructure plan is the upgrading plan. The upgrading plan addresses infrastructure performance issues, ensuring proper service delivery for present condition and for the present supply area. We mustn't be confused with the master plan. But the outputs of the upgrading plan are very important. It enables us to do proper rezoning. It reduces the electricity costs. It reduces the blockages in the different parts of the system. It ensures better pressure distribution, and it provides a solid basis for capital expansion of the network. All that becomes feasible with tools for network analysis. So traditional network analysis was always there. IDAMS also has a very comprehensive model that combines primarily the IPANET engine, but together coupled with artificial intelligence and engineering and optimization routines that automatically perform cost optimization, energy management, risk analysis, and calibration and leak detection. Of course, all these modules, all these systems we discussed, to be able to be properly utilized, you need tools to explore, visualize, and report the results and the data. For this purpose, the multitude of tools, it's a whole management reporting engine that should be in place to be able to produce from simple reports to ad hoc queries to thematic mapping, but most important of all, dashboards. Dashboards is a modern tool that has become very, very popular, and it is used in all aspects of computerization And one of the main advantages is that it provides live reporting with drilling capabilities and feedback, and available in most platforms, from PCs to tablets to mobile phones. I'd like to close with some reports from the operation of SIAM on the cloud. These are typical reports produced by the system and available to more than 100 utilities, from weekly audit trail, statistics for the maintenance department, from call logs, problem logs, investigations, or some other graphs, again, from the maintenance department operation. Thank you for your attention.